Hello dear student, I am Islam. Welcome to third lecture of real analysis. Okay, so in this video we will discuss another 6 question of real analysis that's been asked in CSIR-NET. Okay, so without delay, let's start. See, this is a question of that asked in June 2011. Okay, the question asked in June 2011. Okay, see, this question says that which of the following set is uncountable? Which of the following set are uncountable? Okay, so first of all, looking option 1. Okay, also if you look option 1, you say this contain those real numbers has a log x equal to p by q. Okay, log x equal to p by q. Now from here you can write x equal to e power p by q. Okay, e power p by q. And p by q is coming from set of rational number. Okay, we all know set of rational number are countable, right? So you can count the number x, okay, of the set. Each x you can count number x in terms of p by q. So you can say this is countable, this is uncountable. This set also contains p by q. So p by q rational number. So this set will be made counted. You can count this set also. Okay. So this is also countable. This set this set contains those members has cos equal to p by q. So from here you can say cos equal to p by q means x equal to cos inverse p by q. Okay. So you can rewrite the set this like is equal to cos inverse p by q such that p by q come from rational number. Okay, so rational number sets are countable, so you can say cos inverse p by q, this set will be countable, so this is also incorrect. So remaining option will be correct, but you can verify it. It's saying that this power n equal to cos power x and the sin power x equal to 1 for some unit natural number. Okay, so if you want to verify it, you can verify this. Okay, you can verify this. If you put n equal to 2, you see, if you put option 2, put n equal to 2, so you give cos x square x plus sin square x equal to 1, right? Cos square x equal to sin square x equal to 1, this will hold for all x belongs to real number. Now see, s is a set of those x belongs to real numbers has that this says that cos x power n and sin x power n will be 1. Okay, for all x belongs to, this gives for some natural number, right? And if you put n equal to 2, and this whole is real number, so this is set nothing but a set of real number. Okay, but it is uncountable. Set of real number is uncountable, right? This set of real number is uncountable, you can say it is uncountable. So in this question, correct one is option 2. So hope you understand my solution. Now we are going to second question. Okay, option 34. This question came in June 2010. Okay, so S is the set, is saying that see, S is the set order pair alpha comma beta such that alpha comma beta belongs to Q. So this set is nothing but, remember, from Q cross Q. Okay, these are Q cross Q. Now Q is disconnected, so Q cross Q will be disconnected, so it's incorrect. Now if it is closed, okay, you take closure of Q cross Q is nothing but Q cross Q, closure will be R cross R. Okay, it's nothing but not equal to Q cross Q is say. So S closure is not equal to S. So S is not closed, because if a set is closed, then its closure must be equal to S. Na? The theorem is, if a set is closed, then its closure will be equal to S. So you can say S is not closed. So it is also incorrect. Now option 4. Option S closure is closed. S closed, if you means S complement. S complement will be number R2 minus, you can say Q cross Q. Must means is contained order pair such that each component are irrational. Okay, means you can say it set contain order pair xy such that x belongs to irrational and y belongs to irrational. Okay, this order pair. Then this set, if you take it closer, then it giving R cross R. Okay, not equal to S complement. Okay, so is closure not equal to this set, so you can say S closure also, S complement also not closed, you can say it not closed. So third will be option 2, but you have to verify S. Okay, we all know this result. If S subset R2 is countable, CTBL countable, then you can say R2 minus A, this will be path connected. Okay, you say this R2 minus A will be path connected. but we all know every path connected is connected, right? So every path connected is connected, so you can say R2 minus A is path connected, and R2 minus every path connected, so R2 minus is connected. See here A is equal to Q cross Q. Okay, I have written Q is countable, Q is countable. So find corresponding what countable is countable, na? So this is countable. So you can say from here R2 minus Q cross Q is nothing but S complement. Okay, so S complement will be, since it's countable, so R2 minus Q is path connected. S complement will be, you can say path connected. Now every path connected is connected, so you can say is connected. So S complement will be connected. Okay, so in this question correct option will be option 2. Okay, hope you understand this. Now come to the second question. This question, which the following set are uncountable. Okay, it asking which the following set are uncountable. I am writing one by one. Let S equal to set of all those mapping from R to 2 set 0 on. Okay, mapping R to 0 on. This set is A, you can say this set is B. Okay, so you can say total number of function from A to B. Nothing but current B per current, this is the formula. So current B per current A. Current B is 2, there is 2 element. Current A is equal to C. 2 to C is always greater than C. So a set having current greater than C means continuum. Okay, it's always uncountable, na? So it's always uncountable. So this set is uncountable. So it's asking the uncountable set. So it's correct. Now going to option 2. Option 2 is quite similar. This is a set of all function S2. You can say set of function S2. So the F is mapping from natural number to 2 set 0 on. Okay. So it is countable, uncountable. So is current S2 will be nothing but current B per current A. Is current A, you can say it is A is B. Current B is 2 and current is A. Natural number current is alif naught. Okay, current natural number is alif naught. Now total alif naught is C. You all know. It means total alif naught is continuum. And continuum is uncountable. If you set having current continuum, then uncountable, na? So this set is uncountable. So this is also correct. Option 2 is correct. Option 1 is correct. So option 2 is also correct. Now setable finite subset of n. Okay, this setable finite subset. Setable finite subset of n. Setable finite subset of n. This finite subset will be like of the form this: either 1, either 2, either maybe 1, 3, 1, 2, 3, either maybe of the form. You can say 1, 2, 3, so on, n, so on. This is the form. Setable finite subset of n maybe of the form like this. This contains this set. Okay. So you can say if S is the setable finite subset, if S is the set of all finite, is a setable finite subset of n, then this will imply S is equivalent. There is a biased mapping from S to n cross n cross n. Okay, you can say. So you can say current of S will be nothing but current of n cross n means natural number current. So then now current, this will be current of natural number cross current of natural number cross current of natural number. Now current natural number will be alif naught, right? So current natural number will be alif naught. So this gives alif naught, alif naught, alif naught, alif naught. How many times? This will be n times. You can say now alif naught power n. This will be itself alif naught, na? And set having current alif naught is countable, so this set become countable. So but you are looking for uncountable set. So this countable set, so you have to discard this. So option 3 is incorrect. So you can say option 3 is not correct. Now setable finite subset of n. Setable subset of n means set of power set of n. The current of power set of a set is nothing but current of 2 power z set. So current of power set of n is nothing but current 2 power current of n. Now current of 2 power n means alif naught, 2 power alif naught means continuum C. Okay, so this is uncountable. Since it is uncountable, so you can uncountable, since this is correct option. So in question correct option are 1 to 4. So in question correct option you can say 1 to 4. If you any doubt, you can ask or ask in the comment section. Okay, without any hesitation. Now so we have solved 3 questions. Now these are part B question, this is part B question, and this is part C question. Okay. Now we going to this question. Before this, you can solve this easy question. Okay, I'm solving this. Asking that a set having cardinality A has 3 elements, okay, and B has how many elements? 5 elements. And total number of function for 1, 2. Total number of how many total number of function? Total number of function from a set A having 3 elements to set B having 5 elements. Nothing but the formula current B per current A. So current B is 5 and current A is 3. So total number element will be 125. So total number function will be 125. So one option is correct, but it's asking 2 for 3. It's saying total number function will be 1 to A to B is 2 for 3, not using correct. So option correct. Now total number for option 3 and 4. Total number 1 function. How many injective function? Okay, total number of 1 means injective function will be this formula. You can say npm. It is npm is 5p 3. So 5 factorial 5 minus 3 factorial. So 5 4 3 2 factorial. So 2 factorial will be 60. The total number of 1 function will be 60. So option 4 is correct. So in this question correct option will be option 1 and option 3. Okay, there is a brief theory behind this total number function. How many count total number function, how this formula came, current B over current A, and how this came, npm. Okay, this formula came. There is a brief discussion. You can, if you understand this, please listen to it. Suppose is a set has this set has m element, this set B has n element. Okay, so I'm naming it like this: 1 2 so on m, and this is 1 2 so on n. Okay, now how say how many element 1 can map? You have to create a function from 1 to b. You have to find the image of 1 to m. Okay, so 1 can map either 1 2 3 or n. So 1 has n choices. Similar 2 can map either 1 2 3 or n. So 2 has also n choices. Similar 3 can map either 1 2 or n. So it is also n choices. Similarly, you can say m has also n choices. Okay, so total function will be nothing but this nothing but. So how many times? This is m times, right? This m times because there are m element, na? So total function will be into n. Now into m is current B and a is current A. So total function. So this is the total function formula. The total number of function, total number function from A to B is nothing but this current B per current A. Okay. Now if you understand the total number function formula from total order function. Okay. What is the total order function from A to B? Then you have to restrict some element. Okay. So images, because if you put 1 on, then 1 map 1 to n, then 2 map doesn't map all element. Okay. See, if you want to compute total order function, suppose it has 1 2 3 n m element, there are 1 2 so on n element. You want to compute, it has A has m element and this is B having n element. You want to compute this function which is 1 on. Okay, means injective. So if you want to compute the function which is injective, so if one can map either 1 2 or n. So in case of 1 you have how many choices? N choices. In case of 2, if it 1 map 1, suppose 1 map 1, then 1 map 1, 2 never map 1, because if 2 map 1, then 1 not equal to 2, but if 1 equal to f2. Okay, so it contradicts the injectivity. So f2 will map either 2 3 or n. So 2 have n minus 1 choices. Similarly 3 have, and this f2 12 choice map product, so 3 have n minus 2 choices. Okay, so similarly last element the element m has how many choices? It will be n minus m plus 1 choice. Why plus 1? Because if it is injective, then its cardinality will be n will be greater than m, right? So n minus m plus 1. So you have to make this product. The total number of one function will be, therefore you can say total number of one function will be n minus 1, last element n minus m plus 1. So if you want to compute this, so n minus 1, n minus 2, n minus m plus 1. Okay, so this, and I am making one more thing. I am making this product n minus m with n minus m minus 1 3 1 and dividing this product. Okay, if you divide this product, this is n minus 1, n minus m minus 1 3 2 1. Okay, and this whole thing is n factorial, na? So the whole thing gives n factorial. So this whole thing gives you n factorial, and this gives n minus 1 factorial. Okay, so total gives npm. Okay, you can say this is a Parmodic formula, np. So in this formula I have used npm. In this I have used npm, na, formula. Total on function from a set having current m, the current n will be npm permutation. Okay, you understand? Okay, now we solve 4 question. Now one more question. This question quite similar. 64, this question and this question are quite similar. We will discuss in the next class. Okay, next class is quite similar. I will solve one question and you have to solve one question. Now there one question remaining. The question, this is the question 73. Okay, we discuss this question now. This is also quite similar question. Which the following asking that which of the following question came from June? The question came in June 2015. Okay, in CSIR-NET. I'm naming it S1. Total function of how many function from the set A 1 to this. With the following set are uncountable. Okay, so total function is S1 is a setable function from n to 2.012. Okay, so you can say total. So how many current to S1? S1 current will be, you can say current to B means this is A, this is A, this is B. So total current will, so total function from A to B will be current to B means 2 and current to A means alpha naught. Natural number current to natural number. So 2 by alpha naught. Now total current is continuum, right? Means uncountable. So uncountable. So S1 is uncountable set. So S1 is correct because it is looking for uncountable set. Okay. Now option 2 is mapping from S2 is mapping from A from 2.1 to n. Okay, so total number function is S2 is nothing but total number function from the set 2.1 to n. So its current will be current to B, natural number current to current of A means 2. This is current to alpha naught and alpha naught power 2. This is alpha naught na, because alpha naught power n also gives alpha naught for any finite number. So instead having current alpha naught is uncountable. So it is not uncountable. So 2 is incorrect. So option 2 is incorrect. Now you see this set, option set, the set this is subset. This is subset of this set. Okay, because there is a restriction f1 less than f2. Okay, those set belongs to those function belongs to the set. They say those are mapping from no option 3. Option 3. This option 3 is the set. This is a subset of the set. This see this is written for option 3. If it is a setable function from 1 to settled function from 1 to n. Okay, with the restriction f1 less than f2, right? Subset those function mapping from 1 to 2.7 to n. Okay, now this set is countable. Okay, I proved in previous option 2 is set countable. Now this set this is similar, but there is a restriction. Okay, so this restriction gives some fewer function because it's a restriction, so it contains maybe some fewer function of this or maybe or equal function. Okay, but anyway this set may not be bigger to this set. Okay, this set contains maybe some fewer element, so this set currently will be subset of this set na, but this set is countable. This set is countable, so it is subset of countable set. This set option 3, so it's countable. Okay, so it is n countable, so it's countable, so we will discard option 3, right? Now option 4, this is uncountable set because look option 4. What is option 4? Option 4 S4. When I make it S4, S4 is the setable function from mapping through n to 2.12. Okay, with the restriction f1 less than equal to f2, there is restriction. Okay, then how many is cardinality? Okay, so if it not this, then it is uncountable. You can clearly tell, but there is restriction. Okay, so you have to understand it. See, there is a codominant natural number, so you can number element 1, 2, so and so on. And in 2.7 set, it's domain is natural number, codominant is 2.7 1, 2. Okay, so you have to map. You can map 1. You can map 1 either 1 or 2, but you can map 1 either 1 or 2, right? But if one map 1 with the restriction f1 less than f2, you can never map. If suppose f1 equal to 1, this will imply f2 is either 1 or 2. Okay, but if 1 map 2, then f2 is 2 only, not 1. f2 is 2 only, not 1, because if f2 is 2, suppose f2 is 1, then you have f2 less than f1, right? But f1 less is 2, so if suppose f1 map 2, says f2 maps 1, okay, this is then you have to satisfy this condition, na, f1 less than f2, okay, this one is satisfied, but f1 less than f2, this is f1 is 2 and 2 less than 1 is a condition, na, it never happened, so f2 never 1, so if f1 map 2, then 2 map also 2, okay. So I am saying that two case arises, okay. So if you want to compute images like sequence efficient, then this f1, f2 and f3, f4, f5 and so on, okay. There are no restriction till the element f3, f4, so on, okay. This is also f1, this is f3 has 2 choices, okay. f3 has 2 choices, see, f3 had 3, here 3 is present, so it's 2 choices, either 1 or 2. Similarly 4 has 2 choices, okay. So whatever may be the image of 1, 2, it has also 2 choices, it is also 2 choices, so 2 2 how many times? Argument times, okay. So this gives the current of the set S4 will be nothing but 2 to power argument, okay. 2 to power argument means uncountable, na, so uncountable, so S4 is uncountable, S4 is uncountable set, okay. It not depend what may be this, okay, how many these choices, okay. If you consider any case, then it gives uncountable, because if you consider first case, suppose f1 maps 1 and f1 f2 maps, then it can be either 1 or 2, so you can say f1 f2 f3 and so on. This in this case is 1 choices, in this case 2 choices, 1 into 2, and remaining one is 2 choices, na, remaining is 2 choices, so 2 cos 2 cos 2 is 2 per line not and 2 lines continuum, first case, okay. But if the case happen, then if f1 maybe map 2, then f2 maps only 2, okay. The second case, if f1 map 2, then f2 map only 2, okay, because if it never map 1, is then contradict the condition this f1 less than f2, okay, violating this. So in this case f1, if you count like this, f1 f2 f3 f4 and so on, then f1 has 1 choices, f2 has 1 choices, and remaining has 2 choices, remaining one has 2 choices, remaining element. So how many choices? So in this case also, and product will giving 2 element, na, giving element times, so this total number function will be given 2 element. So in this case also you are giving continuum, okay. So in any case you get the candidate will be continuum, so this set is uncountable anyway, okay. So option 4 is also what you can say, okay. So option 4 is also right. So option 1 and 4 are correct in this question, okay. So if you want to solution, please subscribe my channel and follow my channel. If you any doubt, you can always ask in the comment section, okay. And more video will come in upcoming videos, okay. I will give more detailed solution also, okay, and also theory. Please subscribe my channel and follow my channel and follow regularly, okay. And these 2 questions will ask in will discuss in the next video, okay. These are quite similar question. I have discussed today till I think 5 question, 1 2 3 4 and 5 question, okay. Next video we will discuss another the remaining CSIR-NET question, and also I will take the NVHM DFR question also, okay, chapter wise. So don't worry, follow my channel and subscribe my channel, you will get everything here, okay. So thank you and thanks for watching.